Okay, so pretty much what I'm going to talk about today is an FTC lawyer agent with generative AI. And I know some of those words might sound a little bit confusing right now, but trust me, in a few minutes here, it'll all get explained. So a little bit about me, as I just said, my name is Ryan, and I'm the lead programmer on 8565 Technicbots. So in my free time, I like to do biking, coding, and I have 5 years of FIRST experience now, going into my 6th year of FIRST. Today we're going to be talking about everything about how to develop some sort of AI bot similar to the FTC lawyer, starting from basic principles of the problem to introducing the tools that we use in terms of AI nowadays, and finally moving on to specifically how to implement something like this yourself. Okay, so I'm sure anyone that's done any form of FIRST composition knows that everything is governed by rules. And in the case of FTC, the rules are outlined by 2 main manuals, although moving on next year, there will only be 1 composition manual. But pretty much the rules are outlined in 1 or 2 PDFs, and there's also a separate Q&A forum where you can kind of clarify with people, and the answers are technically the official game rules. So, most teams have something called a lawyer, which is pretty much somebody that knows the rules really well. And that way, if the team has any questions about whether or not this robot modification is legal or this game strategy is legal, they can ask the lawyer, and the lawyer will tell them, okay, this is legal or that's not legal. But of course, while lawyers are very important, there's a lot of limitations, right? So no human can possibly memorize all 130 pages of both game manuals as well as all 400 Q&A questions. And also, they're not going to be available 24/7. If you just finished a match and you think you need a question box, something with a judge, but your team member that's a lawyer is like in a pit interview or something, then there's nothing they can do, and you're not going to be able to question box that. So given these limitations of human FTC lawyers, the next question is, how can we develop some AI that can do better? Because you have stuff like ChatGPT, Google Gemini nowadays, which is super powerful. So of course, naturally, we have to ask ourselves how we can apply that to FTC. And the answer is through something called large language models. And what a large language model is it's pretty much the most popular form of generative AI nowadays, where it's essentially a model that has billions of weights or parameters inside it, and those weights compress a bunch of relationships between text from like billions of documents scraped from the internet. And that way, if you give it some text input, it will spit out a text output that makes logical sense, at least in its eyes. So if you ask it like, what's 1 + 2, then it would hopefully say 3. If it's a bad model, it might say 4, but in most cases, it'll basically respond to any text input with a corresponding text output. And so basically, the goal of this project was to use something like a large language model to provide a sort of chatbot interface so that any FTC team members can talk to it and get answers about FTC rules, thus supplanting the issues with human FTC lawyers. Okay, so in order to actually make a large language model useful, we can't just like take it and give it a question because it doesn't know anything about FTC specifically. And in fact, if you just give it a question, it won't even necessarily answer it. In fact, when you give a question to a large language model like ChatGPT, it has a quote-unquote prompt built into it that helps it answer in a correct way. Because, for example, OpenAI doesn't want it, so that ChatGPT will say like profanity or tell you how to make a pipe bomb or other things that it doesn't want. So in the prompt, it'll tell it, okay, you're a very nice agent that will respond to user questions, and you will not say any bad words, you will not condone illegal behavior, etc. And we're going to do something similar. That's the second technique that you can use to help improve large language models, which is called prompt engineering. The other technique, which is the first one listed here, is called fine-tuning, and that's just where you take a large language model that's already been trained, and then you give it some more examples. So it'll produce something that is more along the lines of what you want, but that takes a lot of money and a lot of time, so that's kind of out of the question for this particular project. And the final tool, and the most powerful one that I'm going to be talking about today, is something called retrieval augmented generation, or RAG. And basically what RAG is you take a bunch of documents and you give them to the AI so it has some sort of context when it answers a question. So for example, in the case of the FTC game manuals, right, you could say, okay, here are some documents for Rule 8 and Rule 9, and I'm going to pass them into my large language model as context. And that way, if you ask it something about Rule 8 or Rule 9, you'll be able to answer it as if it already knew. But of course, we can't just pass in like the entire 130 pages of the game manual because most large language models have something called a context window. So it's not able to actually remember anything beyond like 26,000 characters. So the way that we get around that in retrieval augmented generation is we do something called a similarity search. You can see that there's like that retriever block in the diagram there, and what the retriever block does is it only retrieves like 5 documents, for example, that are most relevant to the question being asked. And how it determines what 5 documents are most relevant is using some like natural language processing concepts using some math. And basically what it does is it converts the documents to a bunch of numbers, and it converts your question into a bunch of numbers, and it looks at how close the numbers are for every document, and then it will return the documents that have the highest similarity score. So here's a system overview of everything that I talked about. You can see that in our backend, we're going to have something called a vector database, which is exactly all the documents turned into a bunch of numbers. And then on the front end, we're going to have a chatbot UI where the end user can ask it questions. And all that's going to be forwarded over to the retriever, which will retrieve documents from our vector database to provide as context to the AI. And the vector database will be populated from 2 sources, one of which is our game manual 1 and 2, which are PDFs, and the second one, which is our FTC Q&A feed. And the Q&A feed you can actually get from the website as an XML file, which is very easy to parse because it's an organized structure. Okay, now the first step in actually implementing this FTC lawyer is choosing a framework.
Are you recording? I'm sorry.
Yeah, I believe we are recording here.
Yeah, it is. Okay, good. Sorry. Keep going.
Yeah, no problem. You can always view the recording afterward if you have like some extra questions that I didn't answer in the session. So the first step in actually implementing something like an FTC lawyer is choosing a framework for all of your AI stuff. Because there's stuff like the OpenAI API or the Grok API, which will give you access to a large language model. But stuff like doing all of that document retrieval and prompt engineering is very difficult to do by yourself. And there are lots of libraries in existence that simplify that task for you. And so the library I chose to use is something called LangChain, which is the most popular, most fast-growing AI framework right now. And it has a bunch of nice utilities and integrations with things like certain backend providers or large language model providers. And it makes it really easy to build something like this lawyer app. And of course, it's not limited to something like this lawyer app. You can do all sorts of things with it. And you can actually see on the right side here, this is the exact prompt that I passed to the FTC lawyer. You can see I told it like, you're a lawyer whose job is to answer first-time challenge questions. And I told it stuff like, don't say superfluous phrases, keep the answer concise. That's part of prompt engineering where you try to make it so that the AI will respond to you in the way that you want it to. And then the other half of implementing something like the FTC lawyer is actually creating a front-end interface that users can chat with it. And the way I did that is using the web's most popular web framework, which is called Next.js. It's React-based, which if you don't know, React is like a web framework developed by Facebook engineers. So Next.js is very easy to use, very easy to deploy. And here you can see an example of like the dashboard that I have where I'm able to do my deployment. And here's some of the main challenges that I ran into when trying to implement this project. The biggest and most important one, which you would probably run into as your first problem on any similar task, is that the agent is not retrieving relevant documents, right? So on my first test run, I asked it, how many motors are allowed on a robot? And you expect it to say 8, but it just said, I don't know. I wasn't providing the context. And if you actually examine the documents that were passed to it, you would see that the rule that specifies how many motors are allowed on a robot were not included in those documents. And the main reason for this was that before, when I first started building this agent, the way I split the PDF into documents was every single page was turned into a document. But the problem with that is that every single page has like 20 different rules, which are all very different from each other. So what happens is the similarity score for every single page is very similar. So the agent doesn't necessarily know which page actually contains the rule that it wants to use. And to split that, all you have to do is split each page into like 10 documents, for example, and have some small overlap between them. And that way it's much more likely to return what you actually wanted to. And another way to improve the retrieval quality is just to increase the number of dimensions, that is the number of numbers that you use to represent every single document, which also improves basically the overall quality of the agent. Another main challenge was that when I had Game Manual 1 documents, Game Manual 2 documents, and Q&A documents, it would always return a bunch of Q&A documents. And that's because the Q&A questions are super specific, so they have a really high similarity score. But if you ask it something like, oh, how many volts are you allowed to provide to a servo, then it would just look up a bunch of questions on the Q&A forum about volts and servos, which don't necessarily actually have the information about specifically how many volts are allowed. So to get around that, I use something called an ensemble retriever, which uses an algorithm to basically weight documents. So you can say, I want 40% of my documents returned to always be game manual 1, 40% to always be game manual 2, and only 20% to always be Q&A forum questions. And because of that, I was able to go from it always giving these super specific Q&A forum answers to actually providing the relevant game manual context. And then another main problem was that when I first started as well, it had this really high latency, where basically when you asked it something, it would stand there for like 5 seconds before giving you a response, or even 15 seconds before giving you a response. So one way around that is using something called streaming, where basically you can, is what ChatGPT and other like chatbots do, where it'll return the word one word at a time. So instead of having to wait like 10 seconds for all of the words to be generated, you wait like 2 seconds and then the words get generated. You can read them as they come out. And the other solution was to try models with less parameters. So some models might have 70 billion parameters. That's a lot slower than a model that only has 8 billion parameters, because computationally it requires 9 times more computations every time you run it. And another one was getting rid of chat history, because every time you want to pass in chat history to the bot, that's extra tokens that it has to process. So by getting rid of that, you can also simplify that process. And the last major problem was that I kept hitting rate limits because I'm kind of broke, so I used a free provider for everything. And free providers always have rate limits because they don't want you abusing their system. And the only real way around that is either to pay money, or you kind of slim down the number of documents provided so that you won't hit that rate limit as quickly. And so here, I actually have a video of the agent, which may or may not play here. Okay, so this is actually the front end that I developed using Next.js. And you can see that I have like text-to-speech enabled as well. So if you ask it a question, you'll print everything back out to you. And then it will actually narrate that back. And you can actually try it out right now at this link right here, w.sh/FTC lawyer. Although, you know, if a lot of people are trying at the same time, then you might run into some rate limit issues, because again, I'm using free tiers for everything.
It's crash.
So you can see here that I asked like how many motors are allowed, which rule states that, what else does that rule state, and it's able to tell me all sorts of information. And you see here that it's very graciously professional, because when I ask it if you can set fire to an opponent's robot, it tells me, no, that's not in the spirit of FTC. And you can ask it anything right now as well if you go to that link. So what are the takeaways from this project? Well, it was, in my opinion, relatively successful. You can ask it questions and it will give you answers back. And you can actually ask it some relatively advanced things and it will tell you the correct answer. So for example, if you said, I'm currently 34 seconds or maybe like 54 seconds into the game, how many seconds left before endgame starts? Then it would do some math and then it would figure that out and tell that to you. And you can actually try asking that right now. And also, for example, I asked it, are you allowed to use a USB hub or an external USB battery to power your USB hub? Which a lot of people think the answer is no, but the answer is actually yes, as long as it has like certain requirements. And the lawyer was able to retrieve that information. So it's very useful because that rule is like hidden very deep inside the game manuals. So a human lawyer would have to spend forever trying to find that, but this lawyer is able to find it immediately. Of course, there's still a lot of cons. So sometimes if you ask it, for example, like if you use the model with low parameters and you ask it, are you allowed to set fire to an opponent's robot? It might say, you know, it's not explicitly stated in the rules that you can't do that, although it's not in the spirit at first. So there's some limitations, and you might have to reword the question like, is it appropriate for me to set fire to my opponent's robot? and then it will tell you no.
It sounds like somebody tried
Might have tried that myself.
that.
But of course, in the future, we can always improve on this by using like bigger models, by paying for app models to get around all the rate limits and other issues. And by doing all that, you could probably get an FTC lawyer pretty close to what a human could do. All right, so I'll take any questions that anybody has now. Otherwise, that's it. Yes.
So you had some, initially, we were looking at models to build, I think, rate of your first model that you get. Your first method of trying to achieve this was cost prohibitive. And then you run into some other technological vending services that you can leverage or use if if they were paid. So if you had to get budget or just throw a number out there to make this to eliminate some of the, we'll say 95% of the costs that you have, how much money would you have to throw at this?
It would be based on how many users and like how many requests you make. So like, if you have like a typical active user, maybe giving like 20 requests a day, it would be really cheap. So I actually checked my provider right now to check the bill. Like it doesn't bill me, but it would say if it were billed, like hypothetically how much it's costing them. It's like 50 cents for everything I've done so far. So even if you actually pay for it, it would still probably only be like 50 bucks a month at most for a ton of users using it very extensively. So I don't think it would be too expensive, but for this project, I wanted to go free, so I didn't use them. Anybody else have a question? Let me check the chat as well. Yeah, I see Demon raising their hand, so go ahead and ask your question.
On a scale of 1 to 10, how hard was this to code? And can a rookie team, would it be useful for a rookie team?
Okay, that's a good question. So on a scale of 1 to 10, probably like a 6. If you first start, if this is like your first project using AI, then it could be a challenge because there's a lot of things you have to know in the first place to get around a lot of the problems that I mentioned. But if you already know how to do that and you already know how to make like a UI, then it might take like 10 to 20 hours and you'll be done. As for how useful it is for a rookie team, I honestly think you could probably use it to get to learn the rules. So if you have questions about like, oh, is my robot allowed to do this? Then you can ask it that, because I know that a lot of rookie teams might not have as much familiarity with the rules. So yeah, I think you could legitimately use it.
Thank you.
Are you gonna open source this?
It is open source right now. So if you go to the link that I posted there, dump.sh/FTC lawyer, there's like a button in the top right corner. I don't think it's accessible on mobile, but if you're on a laptop, there's like a button that takes you to GitHub.
Thank you.
Yeah, no problem.